today we're going to talk about solving linear inequalities. So section 4.6 is a pretty long section. We're going to start with some basic inequality definitions and review. If you took Math 95, hopefully you saw these at the end of chapter 2 in section 2.8. And then once we finish off with our review of our different inequality problems, we'll get into the content for this chapter. That'll be the second video that we'll go through and talk about absolute value inequalities. All right, so our first definition here is that of a linear inequality. A linear inequality in one variable can be written in the form ax plus b is less than c, where a, b, and c are real numbers and a does not equal to 0. Basically, we just have an inequality of the form where we have some sort of variable, some sort of numbers, and some sort of inequality symbol. So a less than, greater than, less than or equal to, or greater than or equal to. Right. Our final answers for these problems are going to be some sort of inequality statement. And then we're going to take that statement, that answer, and we're going to write our answer on a number line. And then we are also going to write our answer in interval notation. So this first page here is just kind of going through and reviewing what direction we want to be moving, things about our interval notation, and how we want to be shading in our number lines. Okay. All right, so to start with, looking at our first example. Right, we're going to talk about x less than 5, then we're going to look at x is greater than or 4, and then we're going to look at some with a less than or equal to and greater than or equal to. As far as symbols go, right, sometimes we can use open dots or closed dots for these symbols. In these cases, I'm going to choose to use parentheses and brackets, or square braces, I should say, because that's how you're going to see answers show up in my math lab. So if we see a less than sign, right, we're going to end up using a parenthesis that goes that way. If we see a greater than sign, we're going to end up with a parenthesis that goes the other way. A less than or equal to, we're going to get a square bracket, and then a greater than or equal to, we're going to get a square bracket facing in the other direction. And I'm just going to kind of put this up in the corner so that way as we go through the problems we have something to refer back to. Thinking about our number lines, we have arrows on each side. They represent positive infinity and negative infinity. And as far as symbols for infinities go, infinities always get parentheses. So when we're dealing with our notation, if we do have an arrow shaded in, we're going to use either a negative infinity or a positive infinity and make sure we have the appropriate parentheses around that value as well. All right, so x is less than 5. It means we're starting at 5 and we're going to go to the left. Right? So to show our direction in our parentheses, right, that is going to be the end of our inequality statement. Right? So on our number line, we're going to put a parenthesis going that way. Right? We know we're going to shade all the way to the left. So we have this entire portion of our number line shaded in where x is less than 5. Right, since we are dealing with real numbers, we are shading in our entire number line. Right, so we're including all of the numbers that are smaller than or less than 5, 4, 3, 2, 1, right, any sort of fractions or decimals or anything in there, and we continue going infinitely in the negative direction. Okay. Right, then our interval notation. Our interval notation is always either two numbers or a number and a symbol separated by a comma and then surrounded by either parentheses or brackets. So in this case, our interval is going from this negative infinity to this 5. So our interval notation is going to be negative infinity to 5. Right. For our next example then, we're going to look at a greater than. X is greater than negative 4. Greater than means we want to shade to the right. So this time our parenthesis is going to be facing this way. That way we can shade our area to the right. We're going all the way out to our arrow in the positive direction. Right? So that is our positive infinity. So our interval notation for this one is going to be negative 4 to positive infinity. Right? Both less than and greater than symbols get parentheses. Both of our infinities also get parentheses. Then our next two examples, we're going to look at less than or equal to or greater than or equal to. Instead of using parentheses for these, we're going to use square brackets. So x is less than or equal to negative 3. Less than means we're going to start at negative 3 and go to the left. Right? And we use the square bracket and we go to the left. Right? We're going towards negative infinity. So negative infinity always gets a parenthesis to negative 3. Right? And since we used a square bracket on our number line, we also use a square bracket in our interval notation. Right? X is greater than 7 means we're going to start at 7 and go to the right. Again, because we have a greater than or equal to, we're going to use our square bracket and we are going to shade to the right. So we are going to have 7 to positive infinity. Right? 7 gets a square bracket, infinity always gets parentheses. Right? So our little key that we used up here to show our symbols, we can see kind of makes sense as we're putting these values on our number line. Right? For most of the problems that we're going to do in this chapter, you're going to be asked for a couple of different parts to your answer. Right? We're going to be asked for some sort of interval and some sort of number line with the correct shaded area indicated as well. Right. When we are solving inequalities, we use a couple of different properties of inequalities. Right? We use an addition property of inequality and a multiplication property of inequality. Our addition and multiplication properties of inequality are very similar to our properties of equality, which basically say as long as we do the same thing to both sides, we're good. The only thing that's different here is if we divide or multiply by a negative, we flip our symbol. And down here, if we look at this, 2 is less than 3. But if we put negatives in front of them, right, if we divide or multiply both of these by negative 1, well, now we have negative 2, and it actually is greater than negative 3. So anytime we multiply or divide by a negative number, we want to make sure we flip our inequality symbol. Right? So underneath here are a couple of key things that we want to keep in mind. Right? When solving inequalities, do not forget to flip the symbol if we divide by a negative. Right? And when we're thinking about and writing out our solutions, we always want our x to be the first part of our inequality statement. So if we have something that looks like 1 is less than x, or if our variable ends up on the right side, we're going to rewrite it in the other direction. So notice that the open part of the symbol went towards the x, so when we rewrite it in the other direction, right, we still have the open part of the symbol towards the x. So instead of writing 1 is less than x, we're going to write that x is greater than 1. All right, so for our next example, we're going to solve. Right? We're going to solve an inequality, and then we're going to graph our answer on our number line, and then write our answer in interval notation. So we have 5x plus 4 is less than 3x minus 12. We're going to treat this just like we would a normal linear equation. Right? I'm going to start by subtracting 4 from both sides. I have 3x is less than 5x minus 16. I'm going to subtract 5x from the other side. Negative 2x is less than negative 16. Divide by negative 2, and that's going to give us that x. Right, looking at this, oh, I just recopied my problem down incorrectly. All right, let's start this one over. Okay, I mixed up my 3x and my 5x, I apologize. Okay, so we still start by subtracting 4 from both sides, right? And we should have 5x is less than 3x minus 16. There we go. All right, now we're going to subtract 3x from both sides. All right, so the 4 is canceled, the 3's cancel. We have 2x is less than negative 16. Divide by 2. Right. 2's cancel. X is less than negative 8. Right. We don't have to change our symbol or anything because we divided by a positive number. Right. We divided by a positive 2. Right. Going to our number line then, we're going to look for our x is less than 8. Right. Negative 8 is here. Less than means we're going to the left. So we're just shading in this very small area on this end of our number line. Our interval notation that goes with this is going to be negative infinity, since that arrow to the left is shaded, to -8. All right, so we'll work through one more of these. All right, so we're going to do the same thing here, work on getting our numbers on one side, variables on the other, just like we would with a linear equation. We're going to add 4 to both sides. 2x is greater than or equal to 7x plus 9. Subtract 7x from both sides. Negative 5x is greater than or equal to 9. Divide both sides by negative 5. Notice that we are dividing by a negative. Right? So since we are dividing by a negative number, that means we want to flip that symbol that's in the middle. So our negative 5s are going to cancel. We keep our x. Instead of having a greater than or equal to, we are now going to have a less than or equal to. Right? 5 does not go into 9 evenly, so I'm just going to leave it as a fraction, -9 over 5. If you really wanted to, you could turn it into a decimal. Right? If we divide -9 by 5, we get -1.8. Either one is fine. Right? Since we're dealing with real numbers, it doesn't matter if we have fractions or decimals. On our number line, right, -1.8 would be right about there, right, somewhere between our -1 and -2. Right, less than or equal to means we get a square bracket, and we are going to the left. Right. Our interval notation, right, since we shade the arrow to the left, we get negative infinity. Right, and then we're going to -9/5. So far, these last two examples that we have looked at, right, they have been examples of what we call simple inequalities. We call inequalities simple when they contain exactly one inequality symbol. So what we have just done in our last examples are simple inequalities. Inequalities containing 2 symbols are called compound inequalities. Right? Just like a compound sentence is made up of different parts, so is a compound inequality. So this is one example of a compound inequality in the next part here. -3 is less than x, and x is less than 4. So first thing we want to do is we want to rewrite this. Right? We're going to rewrite this -3 less than x as x is greater than -3, because we always want our x first. And then we're going to keep the word and in there and say that x is less than 4. Right, so just like a compound sentence can be joined with the word and, so can a compound inequality. We're also going to see examples throughout these sections of using the word or. So on the next page, we're going to look at some or examples as well. All right, so what this means is that x is greater than -3. Right, so x is greater than -3 means we have a parenthesis at our -3, and we're going to shade to the right. But then we're also told that x is less than 4. So that means that we don't want to go all the way over to our arrow over here. We want to stop at that value of 4. Right? And we're going to shade in just this inner portion of our number line here. Right? And our interval that we get is -3 to 4. So a compound inequality, again, we're going to see some cases of and, some cases are or. We have 2 statements, 2 inequality symbols that are being combined into one number line, one interval notation answer. Inequalities that contain 2 inequality symbols together, right, are called double compound inequalities. So what we see here is the statement -3 is less than x is less than 4. Right? We have 2 inequality symbols in the same statement. This that we have here means exactly the same thing as above. So this means that we are going from -3 to 4. So we get our same interval notation from -3 to 4. Right? So this is actually the exact same example as above. Right? The only difference is instead of writing the word and, we wrote it as one statement. You're going to run into a couple of these in your homework. When we are solving these, the key thing we want to think about here, solve all three parts together at the same time. So when we're solving these double compound inequalities, we want to make sure that we solve all three parts together at the same time. All right, so looking at this example then on the bottom, okay, we have -3 is less than 4x plus 2, which is less than or equal to 11. Right, so our goal is to get x all by itself. Right? If we were to look at just say that part of our equation, right, ignore kind of that first part, looking at that, if we were just solving that, we would want to get rid of the 2 first. Well, we're going to do the exact same thing here. Right? The key thing that we want to remember is we want to solve all three parts together. So if I want to get rid of a 2 in this middle portion of my equation, I have to do the same thing to both of the pieces on the outside. Right? So we are working with a 3-piece inequality statement, not just 2 sides of an equation. So on this left side, -2 minus 2 is going to give us a -4. Right? In the middle, these guys cancel, so we have a 4x. Right? We have a less than or equal to symbol here. 11 minus 2 gives us 9. Then we want to finish getting x all by itself, so we're going to get rid of the coefficient. So we're going to divide everything by 4. -4 divided by 4 gives us -1. Keep our less than symbol. 4's cancel, we're left with x. Keep our less than or equal to symbol. Right? And then we get 9 over 4, right? Or if we change it to a decimal, 2.25. In these cases where we have it all as one statement, I'm not going to have you divide by a negative number and flip all of your symbols. We're just going to only have positive coefficients of x here to do our dividing. As far as the statement goes, so we are between -1 and 9/4. -1 is here. Since we have a plain less than symbol, we're going to have a parenthesis. Right? 9/4 is equivalent to 2.25, so just a little bit past that 2. Right? And we're going to shade in the number line in between. Right? So our interval notation is going to go from -1 to 9/4. -1 gets a parenthesis, the 9/4 gets the square bracket. The last example that we're going to do, we're going to look some more at our compound inequalities, and we're going to compare the words and or. Right, so thinking back to stuff that we talked about at the very beginning of the semester when we were talking about sets, we use the word and or quite a bit. Right? So if we're thinking about the word and, right, and should make us think intersection, right? Or should make us think union, if we're thinking about our set theory stuff back from chapter 1. Right? Our intersection, remember, is where our sets overlap. So in this case, it's going to be where our inequalities overlap. And our union, right, is everything and anything that's included. Right? So our union is all. It's either or both. So we're going to use this idea to kind of compare some different inequality statements as we go through using the words and or. All right, so let's look at this first one. So we're going to start with x is greater than 2. Right, I'm going to use my blue pen to indicate this. Right, x is greater than 2 means I'm going to start at the -2, right, and then I would go to the right. So my x is greater than 2, starts at that -2 and then goes to the right. If we looked at x is less than 7, Right? We're going to start at the 7 and we're going to go to the left. Okay. So we have our parentheses in each of these and we are going to the left. Now for our answer, notice that I haven't written anything on our actual number line yet. Our final answer is going to be part that is written in red. Right? We want the and. We want where these guys overlap. Right? They overlap in this middle portion. Right? So on our number line, we are going to shade in just this area from -2 to 7. So an and is where they overlap. Right? So we get -2 to 7. Right, now in B, we have the exact same inequalities to start. So we're starting with x is greater than -2. Right? And our other statement is that x is less than 7. Right? But now we have the word or in here. So our or means we want anything and everything, right? We want all of the parts that have some sort of marking above them. So if we look at this, our entire number line is actually covered by, right, either one or the other or both of these arrows. So in this case, our entire number line is covered, and we're going to continue going infinitely in both directions. So instead of just being this portion in the middle, we are shading in our entire number line, right, which sometimes we can refer to shorthand notation as all real numbers. Right? So there's a big difference between the words and or. Our inequality statements were exactly the same, right? But what we get for an answer is very, very different whether we have the word and or. All right, we're going to do the same thing for examples C and D. Right. One of them is an and, one of them is an or. So x is less than -2. We're going to start at -2 and we go to the left because we are less than. Right. X is greater than 7. We start at 7 and we go to the right. Again, here with the word and, right, we're thinking intersection where they overlap. Right, the next one we're going to be thinking union. Right. So in this one, notice that these two lines, this green and this blue arrow, they don't overlap at all. Right? Since they don't overlap at all, our answer for this one is going to be the empty set. Right. Now, if we start with the same thing and we say x is less than -2, or, right, now we're thinking union, x is greater than 7. Right, we want to shade in anything in our number line that has something either above or below. Right, so we're going to shade in this area leading up to our -2, and then we're going to shade in this area over here starting at 7 and going to the right. Notice that we've been mentioning intersection and union. In this case, since we have two different pieces of our interval, we're actually going to use our union symbol in between them as well. So we're going to say -infinity to -2, which is our piece of our interval on the left, union 7 to positive infinity. So we don't overlap at all. Their intersection is empty, but we do have a union. We can write our final answer as a union here. Right. E and F, we're going to do the same thing. Right. We're going to compare two of the same inequalities. Again, we're thinking about the difference between and or. So intersection and is the word and then union is the word or. Right. So x is less than -2. Right. Means we're going to start at -2 and we go to the left. X is less than 7 means we start at 7 and we also go to the left. So now we look at where these overlap, right? And we have this area down here on the left. Right. So, and where they overlap, right, from the arrow all the way to our -2. So our interval notation is going to be -infinity to -2. Now we use the same statements, only or. Right. So there's our x is less than -2, or x is less than 7. Right, now we want or, so we don't want just this portion on the end where they overlap. We want anything on our number line that has, right, an arrow above it. So that means we're not going to stop at the -2. We're going to keep going all the way until we hit the 7. Right. So our final interval notation for this one is going to be -infinity to 7. So and or, we do want to pay attention to which word is being used, and we do want to think out our final answer on our number line very carefully. And again, we're thinking intersection, or we're thinking union. We want to be sure as we're going through these, again, that we're thinking about all of our answers both on number lines and in interval notation. Going through these examples, I just chose less than and greater than. We can do the same thing with less than or equal to or greater than or equal to. Just remember, if you see a less than or equal to or greater than or equal to, you want to use square brackets for your numbers, but that infinities always get parentheses. And there is a little note down here at the bottom, right? We can solve other types of compound inequalities. So, if we see something such as 3x plus 1 is less than 10 and 2x is greater than or equal to -5, we would solve each one individually, and then we would go ahead and show our statements, and then pay attention to whether or not we have the word and or in between there, and then once we have that done, make sure that we get the correct interval notation in there as well.